Hello, good morning. Let us welcome to my channel, JBTeguihanon Engineering and Chemistry Tutorial. Please subscribe to my channel for those of you who have not yet subscribed, and please hit the notification bell so that you will be notified every time I upload new videos. So let us now have a review of the pressure. Okay, this is very important because we will be always using pressure in refrigeration. So to analyze our system, we need temperature, pressure. This is the thing that we must at least master for our study in refrigeration. Okay, so again, pressure is defined as a normal force per unit area. Okay, that is force per unit area. You have F acting on the surface, your area. Okay, this is your area. Okay, so of course, if you draw it like this, it will be like that, and you will have an area, right? So when you have force per unit area, that is your pressure. But regardless of the unit, it it could be is in SI system. Then the unit will be Newton millimeter square or Newton per meter square or kilonewton per meter square or meganewton per meter square. Okay. Sometimes it could be in bar. Bar is equal to 1 times 10 raised to 5 Newton per meter square or square meter. Or to make it short, 1 bar is equal to zero point 0.1 mega meter per square meter. Okay, sometimes the pressure is expressed in another unit called Pascal or PA or kilopascal. So remember this is very important because sometimes exams can be purely purely a unit based problem. So 1 Pascal is equal to 1 Newton meter square or 1 kilopascal is equal to 1 kilo Newton meter square. Okay, so these are very important because in this reference book that I we are using, this is in SI. Okay, in other book, it is in the English. So I'm using different books so that we can see the approach. This is an engineering approach, an old book, but it's very beautiful book. Okay, textbook of refrigeration and air conditioning by R.S. Cormi and J.K. Gupta. Okay, so move on. So in here we have this what we call gauge pressure and absolute pressure. Gauge pressure and absolute pressure. So in gauge pressure, we have here this diagram. But before we go in there, we read this one. All the pressure gauges read the difference between the actual pressure in any system and atmospheric pressure. The reading of the gauge pressure is known as gauge pressure, while the actual pressure is called absolute pressure. Mathematically, they have this relation. So absolute pressure is equal to atmospheric pressure plus gauge pressure. So this relation is used for pressure above atmospheric as shown in figure 1.5a. For a pressure below atmospheric, the gauge will be negative. So he's referring to this, okay, figure 1.5, and this is 1.5b, sorry, this is 1.5a. So if you have an absolute pressure, okay, from this level here, from here up to there, then absolute pressure is equal to gauge pressure and atmospheric pressure, right? And this is what he said here, Beverly. Absolute pressure is equal to atmospheric pressure plus gauge pressure. Is referring to this graphically, that is in figure 1.5a. For okay, so this is a gauge pressure is known as vacuum pressure. So vacuum pressure, this relation is used for pressure above, I'm reading this, above atmospheric as shown in figure 1.5a. For a pressure below atmospheric, the gauge pressure will be negative. Okay, will be negative. The gauge pressure will be negative. This is now the figure relation between absolute atmospheric and vacuum pressure. Okay, now you have here the atmospheric pressure, or sorry, the negative pressure gauge is known as vacuum. Okay, this is the vacuum now. Vacuum. Therefore, absolute pressure is equal to atmospheric pressure, this one, minus vacuum pressure. Absolute pressure is equal to atmospheric, this one, minus, so absolute pressure is equal to atmospheric pressure minus vacuum. Okay, take note of that. Okay, you have to take it from two perspective, right? So absolute pressure at gauge pressure. Okay, so the standard value of atmospheric pressure is taken as this one, 1.013 bar or 760 millimeter of Hg or mercury at sea level. Okay. In English system, this is 14 something, 14.7 psi. So this is approximated. That is 7 something. Okay. So we know that 1 bar is equal to 1 point, sorry, 10 raised to 5 Newton Newton per square meter, or this is what we call PA, Pascal. Atmospheric pressure therefore is equal to 1 1.013 times 10 raised to 5, or 1013 times 10 raised to 2 Newton per square meter. So it is also known as 760 mm of mercury. Okay, wherein your 1 mm of mercury is equal to this guy here, 1 point, sorry, 133.3 Newton per square meter. And your 1 Pascal, or 1 Newton per square meter, is equal to 7.5 times 10 raised to negative 3 millimeter of each G, or mercury. So these are the basic things that we need to memorize and understand for the pressure, okay, gauge and absolute pressure. Okay, so that is for that is all for now. Thanks for watching. Please subscribe. JBTeguihanon Engineering and Chemical Tutorial. Bye for now. God bless.